Welcome at 30-1 to your first lesson in applications of exponential and logarithmic functions. In this lesson here, we're going to learn how to solve exponential equations, okay? And we've done a little bit before, and that's when we had exponents that were unknown, and we can make them the bottoms the same base. But we look at this question here, we cannot make the same bases, can we? I cannot get this side into base 4 with an exponent. Okay, so what must we do? Well, we're going to have to actually log both sides to solve this. We're going to have to use logarithms. This is one of the three main ways in this class where we're going to use logarithms to solve problems. Okay, so here we go. First step is I'm going to log both sides. Okay, because I can't get them. X here, my exponents, isolated the best we could do. Now we're going to log both sides. My next step is I could bring this x down in front. So I'm going to have x log 4 is equal to logarithm of 12. Now I just divide everything by log 4. So I get x is equal to log 12 all over log 4. And now it wants it into 3 decimal places. So let's turn on our calculator and try this out. We're just going to go log 12 bracket, close the bracket, divided by log 4. And I end up getting 1.792. Okay, let's try the next one here. So first step is, let's see if we could isolate my variable, my variable, yes, x, the best we can. So we have 8 to the x is equal to 36. I just subtracted 4 from both sides. Now I'm looking at this. I can't put 36 to the base of 8. I can make 8 to the base of 2, but 36 can't go to the base of 2. So I can't get common bases. Therefore, I must log both sides. So we're going to log both sides. And this will allow us to bring this exponent down in front so it's part of the equation. So log 8 to the power of x is equal to logarithm of 36. So now we have x is equal x logarithm 8. Because the power law, we can bring that down, is equal to logarithm of 36. Now x is equal to, we divide both sides by logarithm 8, x is equal to logarithm of 36 divided by logarithm of 8. So let's plug that into our calculator. So we go log 8, log 36, and we're going to divide that by the logarithm of 8, which gives me 1.723. All right, let's try the next one here. This one looks a little bit more complicated. As I look, I have x's on both sides, but still, we cannot get the same base. So what I'm going to have to do, I want to put these x's down in front, so I'm going to have to log them. So we're going to go log of 6 to the 3x is equal to logarithm of 3 to the 2x minus 1. Now, I could put my exponents down in front. So I'm going to have 3x logarithm 6 is equal to 2x, subtract 1, multiplied by the logarithm of 3. So I'm going to multiply this into both of these. So I still here have 3x log 6, and we have to go 2x multiplied by this, distributive law, so I'm going to get 2x logarithm 3 minus logarithm of 3. Okay, now, what's the next thing to do? We have x's here, we want all x's on one side. Okay, so let's put all my x's on one side, so I'm going to have 3x logarithm 6 minus 2x logarithm 3 is equal to negative logarithm 3. My next step here is, well, how do I get these x's by themselves? I can factor out an x. So I'm going to factor out an x. I'm left with x, and I have 3 logarithm 6 minus 2 logarithm 3 is equal to negative log 3. Okay, there we go. Now that looks nice. Next thing is, I could combine all of this onto that side, or I'll first divide everything by this, so I get x by itself. So I have x is equal to the negative logarithm of 3 all over. I'm going to also put these in front, so I have log 6 to the power of 3 minus log 3 to the power of 2. And what does this mean? That there means subtraction, so subtraction is the same as division. So I get negative logarithm 3 all over. We're going to have here, I just reversed these power rules. I put that back up to get this. So I'm going to have log 6 to the power of 3 is 216 all over 3 squared is 9. So that's the division rule. Okay? Now, what does this equal to? Let's put in my calculator. We have log 3 divided by the logarithm of 216 divided by 9, and push enter. I'm going to get 0.34. Oh, and it's negative because there's a negative in front of this, so no answer. 0.346. So we get negative 0.346. Okay, let's try this next one here. Same idea. We have to first isolate this the best we can. Isolate for our x's. I can't, can I? We have a problem here. We have this and this. So I'm going to log both sides. Let's isolate the best we can. We have log, and I'm going to end up getting 2 bracket x, whoops, we have here 3 to the x minus 2 is equal to 7 to the x. Oh, we have to log both sides. Forgot to log that. So we have log 7x. Now we could drop down my exponents, but this one we can't quite drop down exponent because the exponent is only related to that 3. It's not related to that 2. So we're going to have to separate this. The product law is the same as when we have two things multiplied in the log, we could separate them into two logs of addition. So I'm going to have log 2 plus log 3 x subtract 2. Now I can bring that x subtract 2 in front. We have log 7, and I'm going to bring that x in front. Okay? So we're left with log 2 plus, now we're bringing all my exponents down. I'm going to have x subtract 2. Log 3, logarithm of 3 is equal to x logarithm of 7. Now we multiply these out. We're going to end up getting x logarithm 3 minus 2 logarithm 3 is equal to. Now my next step here is we want to get x's all by themselves. So I simplified everything, and now we could get x's all by themselves. So we have no more exponents. Got rid of that. Let's get the x's by themselves. All right, here we go. So I have logarithm of 2 minus, well, I'm going to move this 2 back on top. So I have logarithm of 3 squared, because I got rid of all my variables and my exponents, is equal to. Now I have to subtract, well, x log 3 from both sides, so I'm going to have x log 7 subtract x log 3. Okay? Now this side here, I could use the division rule, put them together. So I'm going to be left with log 2, and this is the same thing as 9 over 9. Right? The quotient rule means subtraction, that's quotient rule. It's equal to, here I'm going to factor out an x. So I'm going to be left with an logarithm of 7 subtract logarithm of 3, because both of these can be divided by x, so we could factor out that x. Now I'm going to move this all to that side. But before I do that, this is the quotient rule. So this is the same thing as 7 divided by 3, logarithm of 7 divided by 3. So we end up getting logarithm of 2 over 9 divided by logarithm of 7 over 3. That's equal to x. So let's plug that into our calculator and see what our decimal is. Okay, so we have logarithm of 7 divided by, 2 over 9. 2 divided by 9, bracket, and we divide that by logarithm of 7 divided by 3. And I'm going to end up getting negative 2.4, I believe. Just wait, 2 over 9, 7 divided by 3. Oh, I multiplied them. I had to divide them. Sorry. That's why it looks a bit off. So we have logarithm of 2 divided by 9, bracket, divided by logarithm of 7 divided by 3, bracket, Enter. There we go, negative 1.7705 equals negative 1.775. And that's my answer. Thought that looked a bit funny. This should have been bigger than what we had, right? Okay, so there we go. The next part here is, it says, in simple cases, if we have 2 to the power of x is equal to 50 or 4 to the power of x is equal to 12, we could use our equation from before. So we can use our equation by switching this straight into a logarithm. So let's convert this one here. So this is the same thing as log, we're in base 4, so x is equal to log base 4, and we have 12. All right? Now, if you remember, this is the same as, if we were to punch into our calculator to calculate, it's the same as log 12 all over, remember change of base, all over log 4. So that's another way of doing that. I'm going to use this method here on the second question. So the second question is, according to Statistics Canada, in the 21st century, Canada's population has been growing at a rate of 1% per year. Now, the exponential equation they use is this here, where this is my final population is equal to the original population multiplied by 1.01, because 100% plus 1% is 1.01 per year, okay? Can be used to describe the population and years for the population of the original population, to the increase. So this is an exponential growth. Now, let's take a look at this. So we want to know when the population is 50 million. Right now it's 2001, they say it's 30 million. So we're going from my initial, we want my final to be 50, from my initial 30 million is equal to, and my formula, 1.01 to the power of n. Okay, that's what we're trying to do. What am I going to have to do? Divide both of these by 30, so I'm going to end up with 5 over 3 is equal to 1.01 to the power of n. Now, I look at this, I cannot get these into the same bases. Once again, we're stuck with an exponential equation that cannot make the same base. So I'm just going to put this in logarithm form. I know that n is equal to, we have the log, and its base 1.01. 1.01, and we have, that's 5 over 3. So this is the same thing as logarithm of 5 over 3 divided by the log of 1.01. Okay, so I punch that into my calculator right now. So we have log 5 divided by 3. Okay, bracket, and we divide that by the logarithm of 1.01. And I'm going to get 51.3 years. So 51.3 years. And I'm going to say, well, through 50 million, population will reach 50 million. Well, that's going to be, after 52 years, we're going to be over 50 million. So I'm going to say 52 years. So in the year 2053, our population will be over 50 million. Okay? See how that works? All right, let's take a look at this next example here. So we want to solve for this one. First, put an exact value, and then we're going to put into decimal places. So let's try the exact value here. All right, so my best is we're going to isolate for the variable x. Remember, e is a natural number. So we're going to have here, we have 7 e to the negative 2x. And I'm going to move the 9 to that side, so it's equal to 3. All right, so I just subtracted 9 from both sides. Now, I'm going to divide both sides by 7. So I get is equal to 3 over 7. That's as far as I could go. So it wants it in 3 decimal places. All right, so if I do this in 3 decimal places, I'm going to have to log both sides. So I'm going to log both sides. So I'm going to say log e to the negative 2x. But we're going to use natural log because we're looking in, if you remember, if we're using e, we're using natural log to solve. So I'm going to say is equal to, here we're going to have the natural log of sorry, let's see here, what was it? 3 over 7. Okay, so now let's continue this. I'm going to get negative 2x is equal to the natural log of 3 over 7. All right? Okay, so what does this equal here to? This is the same thing as, well, this is like saying log e. Well, that's going to be 1, right? E to the power of what is equal to e? 1. I could even punch that in my calculator. It's going to give me 1. So I get negative 2x is equal to the natural log of 3 over 7. So I get x is equal to negative the natural log 1 over 2, the natural log of 3 over 7. I could have used logs as well, and we would have eventually got the same answer for log both sides. But I was just using natural log here to help you. So I have negative 0.5 multiplied by the natural log of 3 divided by 7. And that's going to give me 0.423. Okay? And that's my answer. So you could have done it in a couple other ways. All right? And that's how we get that. Okay. Here we go. Our very last question here. It says, consider this equation. Use the intersection method on your calculator to nearest tenth and to solve. So we're going to use the intersection method. Last method is by graphing. Okay? So we go y is equal to, and I'm going to clear that. We want 4 to the power of x. Okay? And y2, we're going to put 7. And I'm going to graph it. There we go. And there's 7. See how that looks? Now I'm just going to find my intersection. So I'm going to go second, calculate. I want the intersection. First curve. And yeah, there's closer. Second curve is around there. Guess there. So I get 1.403. So it looks something like this. It's an exponential growth. This is going to be there. Oops. It's a bit off, so it looks like this. And we intersect at 7, and this is 1.403 up there and 7. Okay? Now here's the zero method in the equation to calculate. So we want to use the zero method. That's the second method. So I'm going to clear that. And we have this here. And what is this the same as? I could rearrange this to 4x subtract 7 is equal to y. And that's going to be my zero method because I'm going to shift it. All I'm doing is I'm shifting this graph 7 units down. So my graph is now going to look like this. Because it's shifted 7 units down. Oh, it crosses here at 6. That should be at 6. And it's going to look like that because everything was shifted 7 units down. So we subtract 7. It's going to look like this. All right? See that? Now we're going to second calculate my 0. Left bound, there. Right bound, there. And I guess that's around there. So I get 1.403. Same thing. And that's it. Hopefully you understood this. Good luck as you try and solve the questions tomorrow in class.